welcome to Planck's constant number 1. This is where we're going to talk about how we calculate frequency and wavelength and with the speed of light. So far we've talked about the colors that are produced and that each color has a different wavelength and a different energy. Energy and frequency we talked about the other day also is that the higher the energy, the higher the frequency. Excuse me. So if the wavelength increases, your frequency is going to decrease, and vice versa. If your frequency, if your wavelength increases, your frequency decreases, and if your wavelength decreases, your frequency increases. Okay, so they're inverse to each other. They are like a seesaw. They go back and forth. Okay, so how do we calculate this? Well, we have a formula for it. It's called C equals wavelength times frequency. So C stands for speed of light. So the speed of light equals your wavelength times your frequency. So here's your speed of light. This is the upside down Y is wavelength. Your frequency is a V. Okay, and then we're going to give you the speed of light, which is 3.0 times 10 to the 8. You've seen this before in your packet. Okay, your frequency, your wavelength has to be in meters. So it has to be in meters. And your frequency is either in hertz or your seconds. Okay? So you're going to have to rearrange your formula. So I've done this for you. Speed of light over frequency gives you your wavelength. Speed of light over wavelength gives you your frequency. All right. The paper that I gave you in class, you're going to do with me up here. I'm going to read the question and then do the problem. So, excuse me. The first, number 1 says, what is the wavelength of a wave with a frequency of 3.76 times 10 to the 14th seconds? So what you're going to do is you're going to circle that number and you're going to label it with a V. Okay? You're going to underline wavelength and you're going to put a question mark over that. All right? So that's what tells us which one of these to use. So since we're looking for wavelength, we're going to use this one. So I'm going to plug in my numbers. The C is the same, so it's 3.00 times 10 to the 8. And we're going to divide that by our frequency. And our frequency we circled and labeled as 3.76 times 10 to the 14. We're going to plug this in our calculator, like I showed you in class. Okay, and then you're going to end up getting, when you do the math, you just take this divided by this, you get 7.99, and we want 3 significant figures because we started with 3 on both of them. We're going to end with 3 on both of them. So we're going to get 7.99 times 10 to the negative 7, and then this one was meters per second, and this one was seconds, right? Yes, seconds minus 1. So these cancel. And we're left with meters. And you're going to box in your answer. Okay. Significant figures are going to play a part in any math that we do from here on out. So you will be counted off if you don't have the right significant figures. We started with 3, we end with 3. Okay, let's do number 2. If you want to fast forward while I erase, go right ahead every time I erase. So you don't have to wait for me. Okay, so the next one. Number 2 says, what is the frequency of 6.9 times 10 to the negative 7 meters in a wave? Okay, so we're going to circle the number 6.9 times 10 to the negative 7 meters. You're going to underline frequency, and you're going to label those with you're going to label your meters with the upside down Y. And you're going to put a question mark with a V. Okay. You're going to start plugging in your numbers because we're looking for frequency. So we're going to start with our speed of light. And we're going to put it over our wavelength. In this case we have 6.9 times 10 to the negative 7. These cancel, so we're left with seconds. Okay. And our number is going to be, in the calculator, you're going to get like 4.35 something. So our number is going to end up, because we have 3 significant figures here and 2 significant figures here, so we're going to round it to 4.4 times 10 to the 14th meters. I take that back. Sorry, take that back. I just noticed it was frequency S minus 1, or you can put hertz. Okay, box in your answer. We'll put hertz on this one, because you can use either one. Okay, so that is our answer for this one. Okay. All right, so the next one. Again, fast forward if you want to. Okay, so the next one, number 3. This time we're given, you have a wave that is 943 nanometers. What is the frequency of the wave? So here we are given, we're going to circle 943 nanometers. And we're going to label it with a lambda or an upside down Y for wavelength. We're going to underline frequency, because frequency is what we don't know what we have. I'm sorry, take that back, that's a V. Okay. So we have nanometers, but I told you we needed meters. So how do we get nanometers to meters? Okay, well, we're going to have to bring back one of our old friends, this lovely little railroad track. Okay, so we're going to have the conversion factor. Our conversion factor is this. Okay, so we're going to have 1 nanometer. Sorry, it's taking me so much. 1 nanometer equals 1 times 10 to the negative 9 meters. So we're going to plug in this into our railroad track. We're going to use our conversion factor, but before we do that, what's up on top has to do what? Correct, go down on the bottom, nanometers. And then what we're looking for goes on top. Now you plug in your values. Nothing goes here. You don't need anything here. Okay, so don't put anything here. We're going to put in our 1 nanometer here and our 1 times 10 to the negative 9 up here. And if you remember, what's on top gets multiplied, what's on the bottom gets divided. But we're going to cross this out, because we only need 1, so we're going to just multiply that. You're going to end up with 9.43 times 10 to the negative 7 meters. Now we can plug that into our formula right here. So we're going to take this, we're going to change it to 43 times 10 to the negative 7. We're going to put 3.00 times 10 to the 8th on top. We're going to put it in our calculator, and we'll get our frequency. And our frequency is, and I have this in here in my calculator, how many significant figures? We need 3, so it's going to be 3.18 times 10 to the 14 hertz. Okay. All right, so what I want you to do when you come to class is you're going to do number 4, 5, and 6 by yourself and bring those to class so we can discuss them. Okay? I will see you guys in class.